Hello everyone, this is Mr. 13 Things coming at you in the series of what you learn when you learn to run your TI83 calculator and why it should not be confined just to math class. So we've set and talked about variables and states. We're actually going to dive in here and to show you one of the first things that you really see some great value out of this calculator, and that is in fact the use of the parametric mode. Somehow that seems to have been missed, at least in my kids' school, and this delving of how rich your information can be when you think about equations parametrically. So like usual, we turn on the calculator. First thing we do to turn on is turn it on. We check the mode. In this case, we'll think everything is set okay because we've got it in radians, if you would. And we're just going to then go down here to the point where we're going to talk about things being parametric. And then also the idea of things being shown simultaneously, and we'll see whether that makes a difference later. And we'll leave that as it is. We're going to say second quit. And we're going to then draft a function that we know the answer to, and that is x equals time and y equals time. And we're going to right away just go ahead and graph that and see what we got. Oh, we've remembered that there's something about setting our window correctly, or our settings. We want time to go from 0 to 2 pi. That's fine, but we want to remember that the x and the y aspect ratio is a little bit off, so we want to go ahead and go down here and set the x minimum. We're going to set this to 0, if you would. The x maximum 160, and you'll see why in a second. Y minimum of 0, and the y maximum of 100. And once again, we're going to go ahead and graph and see, oh, that kind of makes sense. Is it in some way it's going from someplace to someplace else? Now if we go back and reset the window, instead of 0 to 2 pi, we're going to go down here. We're going to go from 0 to maybe 10, let's say 20, let's see, star. Well, let us do this. Probably not. 20 times second pi. See how that works. And now when we graph, you can see that it kind of is graphing a 45-degree line, and we kind of have what we want. So once again, double checking that your calculator is giving you something that makes sense. Now we can go back and look at what we can do with parametric equations. And one of the most important parametric equations we might have is just dealing with a ball going up and down. So we can go ahead and think about the x always being the same value, maybe 50, so a ball going straight up and down. Oh, Matt. Second quit. It doesn't like that, so we're going to go back to here. And we, of course, wanted this to be time and time. That's the one equation. But we want the x value always, let's say, to be something like 50. It's going to go straight up and down. And the y value will be one of the first things you learn, I think, when you start dealing outside of linear equations, is the parabola of the motion of a parabolic free-falling motion. And that equation, and I'll put it up here just in the short term, remember, it's basically minus 9.8, which is the acceleration, times the time squared, plus the initial velocity, plus the initial position. So if we're going to go ahead and put the initial position maybe someplace at 100, and we're going to put plus 100. And we're now going to graph that. And we'll see what up. You see that ball just fell down pretty quickly, didn't it? We'll do it again. We're going to graph, and we're going to clear and hit graph again. Now, because of the way things worked out, you don't necessarily get that movement that you otherwise want. So we're going to look at it a little bit differently now and think about it this way. Go back to this equation here. And this time, instead of the x being consistent, we're going to have the x have a constant velocity. So we're going to go down here, and the x is going to be equal to, and why not, t. Hitting the delete key. So the x has got a constant velocity t. velocity in x, and so the value of x will be equal to t. And now when we hit graph, we get something that looks like that. That's still not necessarily any good. We're going to go back to here and realize that our x is t and our y is something like that. Well, we can, all of a sudden, we can change our velocity here to make it maybe 10 star t. Going backwards again, delete, delete. And very quickly what you want to do is you want to learn to play around with something that you can see in real space, and that would be throwing a ball. 10 times t, and graph this. Now we're starting to see that something that looks like makes sense perhaps. And in a second we're going to change that one more time. We'll go back to y equals, instead of 10t, we might want to go towards 20t. So, and we'll talk about what this means later. 20 meters per second is that velocity, and this velocity starts at 0, but it's at an elevation of 100, and we graph it and we get something like that. Now it all is a little bit too speedy, but you see that they're doing this as you do this. I'm going to hit a clear, and you do it again, you graph. The process, when we go back to mode here, if you notice that idea of simultaneous or sequential is kind of lost on you. But that basically is running both of those equations, I think, simultaneously. And we'll see that in a second when we go back again to the layout here. Instead of x being t and y being t, x can be perhaps 10 typing on my keyboard, star t. 11 works, and the next one will be 11 star t, and we'll see what happens when we graph this. You can start to see that it's showing you in simultaneous, and we'll do it, switch the mode now so you can see the difference. Sequential, second quit, and now when you do the graph, it's going to do one and then the other. So that's one of the settings you see. So finally you start playing around with different things, and this starts to be what is a good 3 to 4 weeks, 3 weeks often in a physics class. But some believe in physics first, which might be 7th grade or might be 9th grade. So you start to learn to use a machine that you pick up and check that it gives you the answer that you expect of something you know, that keeps track of states, that teaches you to program, and that's not necessarily math class. That would appear to me to be life. And so if we go back here and change that now we can give this an initial velocity. If we go down here to this equation, this is the acceleration in meters per second, and we can do it with initial velocity here of maybe 100 in the y. So 100, back, 100. And I don't think you need to put the star, but we'll put it here, star t, right? And starting at 0. So now when we hit graph, up, kind of a high velocity set us off the screen. So once again, we might want to do this instead. The window is going to go from 0 to 160 to 0 to, and learning to do this by hand, if you would, is a good thing. It teaches you how to deal with voltmeters. It teaches you how to deal with ranges and orders of magnitude. So now when we graph again, there's that 45-degree line, and there is my parabola, which means I can go back here again and change that. Maybe not 100, maybe we'll make this now 300 and see what comes out of it, and hit a graph. And there's the 300. You see it go up and down. We can go back again, and you start to iterate and change. Very quickly what you learn is you learn to jump into other software. So I think it's got a better screen. Hit graph here. Remember, this is not being simultaneous, so there's your equation, but more likely now you might be very interested in then playing around with the mode here and going back to simultaneous. Changing the state of your calculator so that it deals unless you do with what you want, which is concurrent work. And so as you do now graph, you can see these things happening at the same time. So that rocket doesn't quite hit it. And then you go back and say, maybe we want that not to be 11, maybe we want that to be 13. We want it to be a little faster, right? And you're now in the point of experimental play. When you figure this out a little bit too slow, we'll try it one more time. You could actually go through and trace over time, right, what happens over time to these two functions. And we go back here, y equals, let's go ahead and try it finally with 15t. Graph. And you can see that it still is a little bit delayed. So that is how we learn to use our calculator to look at parametric equations, start to play around very quickly. Since I've gone over anyway, we can then do this, which is going to teach you the final bit of one of the things we looked at before. Instead of just having what we put in here, we can then pull the variable. So in this case, we can do the variable and the y variables, which is not a good description of them, the parametric. So we can take the value of put that plus 20, let's say. Whoops, missed something wrong there. We're going to go back to here. We're going to go down to here. You notice I can't just type these things in, but we'll now put plus 20. And the next one will be, again, we go to variables, we go to y variables, we're in a parametric equation. We're going to grab that one and we're going to say plus 20 as well. And we can, again, graph. And when we don't see it, it's actually filling in an equation right along here. So we can see that perhaps by going to here and actually by hitting that, you see that this one is not graphed. And we can hit this one, that is not graphed, and now it is only this third function that is graphed. And when you hit graph, that's the graph you see. So this has been learning how to use parametric equations and additionally how to feed one parametric equation into another. Thanks for listening.